Let's take a look at the process of multiplying rational expressions. To multiply two rational expressions, like we see here, I can multiply the two numerators together and also multiply the two denominators together. So taking 8x to the 7 divided by 3t cubed times 9t to the 5th divided by 64x, putting the numerators together, I get 8x to the 7 times 9t to the 5th over 3t cubed times 64x. And now there's not a whole lot more to do, except I should always think about, with a rational expression, I want to think, could I simplify that? Could I write that a little bit more simply? And so there are a couple things that we could do. So multiplying those numbers together would be something we could think about. Multiplying the 9 and the 8 up top and the 3 and the 64 in the bottom. But before we do that, let's think about whether there are any common factors. Well, looking at the numbers and thinking about their factors, of course, 8 and 64 have common factors. They're both even. So 2, of course, divides into both of them, but of course 8 times 8 is 64. 8 divides into 64 8 times. And so I can cancel the 8 up top with the 64 because 8 is multiplied with everything else up top and 64 is multiplied with everything else in the denominator. So those are common factors of the top and the bottom. And likewise, 3 and 9 are common factors. 3 divides into 9 3 times, and so I can cancel the 3 with the 9, and it leaves a 3 behind up in the numerator. So a simpler form of this expression is 3x to the 7 times t to the 5th, moving that 3 times 1 to the front, and similarly 8t cubed times x. But we can do even more because the variables have, the variables are in common and they're multiplied with everything else. So x to the 7 is multiplied with everything else up top, x down here. I have 1x. So subtracting the exponents tells me I'm going to be left with 6 x's in the numerator. And similarly, 5 minus 3 is going to leave us with 2 t's in the numerator. So both of the variables are canceled from the denominator. Right? The 3 takes away 3 from the 5 up top, and the 1x takes away 1x from the top and leaves 6 behind. And so our final answer, the multiplied and then simplified expression, is 3x to the 6th power times t squared divided by 8. A second example is a little bit more complicated. Things become a little bit more complicated if we have more than one term. In this case, not quite all of them, but most of the polynomials have more than one term. So we can use the same process. The two numerators are going to multiply together. Now, it's important that I use parentheses to show that both of those terms, x squared and minus 16, are multiplied with x squared and minus 4x from the other numerator. And in the denominator, it's okay for the x squared to not be in parentheses. It could be, but I definitely need to put x squared plus x minus 20 in parentheses to show that all three of those terms are multiplied with x squared. Now here's what's really important. Before I multiply this out, there might be some common factors that cancel. These expressions, the expressions in parentheses, we might be able to split them up into smaller parts. So what I would encourage you to do is pause the video for a moment, think about how you could factor each of these expressions in parentheses, how you could factor those, and if there are any common factors that we could then cancel. In just a moment I'll work through the process, but I encourage you to think about it on your own for a moment. I hope you paused the video to think about what we could do next. And let's take a look. So you may have noticed that x squared minus 16 is the difference of two squares. So I can write that as x plus 4 times x minus 4. And then here, both of the terms in this second set of parentheses share a common factor of x. So let me now put that in parentheses. I can factor out an x, and then what's left behind is x squared leaves an x behind, and 4 times x leaves a 4. So we end up with x minus 4. Just looking at that last set of parentheses. In the denominator, of course, x squared is x squared is x squared. That's just a factor all to itself. And x squared plus x minus 20, for that I want to think about a factor pair that multiplies to equal negative 20. And we usually don't write it here, but I want it to add to equal positive 1. So negative 20, that tells me that the factors are going to have different signs. Right? So I could go through the list if I'd like, 1 and 20, 2 and 10, and so on. And because I want the result to be positive, I know the smaller factor has to be negative. So 3 doesn't go into 20, but 4 and 5. 4 times 5 is 20. And of course, those two add together to give us a positive 1. So that means, because it's a simple situation, we don't have anything in front of x squared. So that means the factorization is going to be x minus 4 and x plus 5. So now to work toward our final answer, what that means, looking at what I have here, I can look at each of the things in parentheses and think about each of those as factors. And so looking at the things in parentheses, even the x, I want to think, is there anything that's common? So if I take this whole x plus 4 together, is there anything that's the same in the denominator? Well, there's an x plus 5, but there's nothing that's exactly the same as x plus 4. So that doesn't have a common factor. However, there's an x minus 4 up top and also an x minus 4 in the denominator. So those are common factors. So those that whole thing together cancels from the top and the bottom. Of course, there's another x minus 4 up top, so that one will still be part of our answer. But one of the x minus 4s cancels with the one in the denominator. In a similar way, this single x up top and x squared is just x times x. So that x up top cancels with one of the x's down here, but there'll still be one left behind. Right? So it takes away one of the two x's that made up x squared. And so our final expression, what's left up top is x plus 4 times x minus 4 divided by x times x plus 5. And now because x is just a single expression, I don't need parentheses around that, but I do need parentheses around the x plus 5 because both of those terms are multiplied by x. And of course I need parentheses around x plus 4 and x minus 4 because they're multiplied. Both of those terms are multiplied with both of the terms in x minus 4. So typically, for these expressions, it's generally usually okay to write a factored form as our final answer, especially because that makes it very clear that there's nothing else that cancels. We could multiply it out at this point. I didn't want to multiply it out ahead of time because then it would be hard to see those common factors. But I could multiply the expression out at this point to get an alternate version. But typically this would be an okay answer in most situations, to have both the top and the bottom completely factored. If I did multiply that out, of course the top, it becomes the difference of two squares again, x squared minus 16, because this x times that negative 4 and that 4 times positive 4 times x, those two terms would cancel. And in the denominator we end up with x squared plus 5x. So if we think for a moment, can I make this any simpler? The answer is going to be no, right? Because we looked at what all the common factors were and there was nothing left that's the same. I just mentioned that though because, be careful, x squared up top and x squared in the bottom, even though they look the same, they're added and subtracted with other stuff, and so I can't cancel those x squareds. So we can only cancel common factors. So this would be another version of the final answer, but be aware, I can only cancel common factors, and x squared is not a factor of that expression. So I can't cancel that. So if I multiply it out, I just need to then leave that alone. I hope you enjoyed the video. Thanks for watching.